Okay, in this lesson, we're going to be learning about position, time, displacement, time interval, and coordinate systems. Okay, so there are three main types of coordinate systems. The ones we're going to deal with at the beginning are the horizontal coordinate system, vertical, and one that's tilted. The one that's horizontal goes left to right. You can always remember this horizon term. The horizon is kind of from left to right. And we're going to use the coordinate system to describe the position of an object. Okay, we need some kind of reference frame or coordinate system to do this. So for example, and on the left side over here, this would be our west or negative direction. On the right over here, this would be our east or positive direction. Okay, so and also the coordinate system has defined 0 or origin. Okay, and we also need to have a unit. Okay, so we would say here that this apple is at position plus 20. Okay, we can say 20 meters east, but we will write this because it's in 1D. We sometimes call this the x-axis, so we can just say that x is equal to plus 20 meters. Okay, that's a nice quick way of writing this in what we call 1D notation. Okay, so in the vertical axis, we have this is north or the positive direction, and this is south or the negative direction. Okay, so the fish here would be at 40 meters south, or y is equal to negative 40 meters. Okay, so notice that the south direction is negative. That's why our 1D notation for this looks like that. Now we could also have a tilted axis where we can specify the x direction as along the hill. Okay, so the position for this car would be x is equal to plus 20 meters. Okay, so now we saw in the last lesson that we can represent motion with a particle motion diagram, as we see over here. But what's difficult to see from these 5 dots here is whether this is a screeching halt or a leisurely stop. Okay, and the reason for that is because we do not know the time difference or the time interval that this is taken at. Okay, so we need to have timestamps on top of each particle in our particle model. Okay, so we need timestamps. Okay, and so here we would see that this is kind of moving at constant speed, and this is braking to a halt. And we can set time 0. Okay, this is what I was trying to get at here. We can set time 0 if this is somebody moving at constant speed here, and then over here they're coming to a stop. Okay, we can set time to 0 to mean right here, or if we're just interested in the braking motion, which is right here, we can set our time 0 at this point here. Okay, so where we start our times equal to 0 is totally up to us. It will all depend on what type of motion we're interested in. So motion measures changes in position and time, and so we call this displacement. Okay, so if I started over here and I moved over here, my displacement would be that much. Okay, I would go from an xi, so initial position, to an xf, a final position. Okay, and so the displacement is sort of our change in position. It's how far out of place something is. Okay, and you might notice that this triangle here is called delta. You might notice that from math. and we say that's change in. And this here is the final position, and this here is the initial position. Okay, so in this example, our displacement is xf minus xi. Our xf is -2 minus our xi, which is our initial position, which is +3. So we have a displacement of -5, which is the same thing as 5 meters west. Okay. So note that displacement can be negative. Okay, so we can have this negative here. It's a signed quantity. Okay, and so up here we have timestamps, but we can also have change in time interval. Okay, so we have the change in time interval between when this thing started breaking would be t final minus t initial, just like in our change over here we have something final minus something initial. So when we have a time interval, that's called a change in time. It's called delta t. So if we want just delta t, final 7 seconds minus 4 seconds will give us a time interval of 3 seconds. That's pretty straightforward. But time interval is always positive. And this is because t final is always greater than t initial.